All right, we'll go through our warm-up. Both of these questions represent questions that are going to be similar to questions that show up on your quiz. The first question is, what is the domain and range for any exponential function? We did look at this when we looked at our graphs for exponential growth and decay. We should know that the domain of any exponential function, it doesn't matter what it looks like or what the numbers are, is all real numbers. You can write that in words, or we can use our symbol, which is that fancy R. Your range, we should know, is all real numbers above 0. So we could put all real numbers above 0, or we could use our symbols, which would be all real numbers greater than 0. That's true for any exponential function, so make sure that you know that. Question 2 practices one of our exponential growth or decay questions. So this says a particular type of bacteria doubles every hour. And suppose you start with 24 bacteria. We're going to write an exponential equation to model this situation. Now, if you remember, our exponential equation looks something like this, where A is our initial value and B is our growth factor. So we're looking for our initial value and our growth factor, and then X is going to represent time. So my initial value I see is that 24 bacteria. So I'm going to go ahead and write y equals 24. And then we'll be multiplying by our growth factor. Now in this question, I don't see a percent, but I do see the word doubles. And that's just indicating our growth. So we're growing by doubling. And if we're doubling, we would multiply by 2. And if we're multiplying by 2, I can just put 2 as my growth factor. We don't have to consider 100% because this isn't a percent. We only add or subtract 100% when we have a percent. But in this case, doubling just means multiplying by 2. And then we'll go ahead and leave our x as an exponent. We'll just leave that variable. Later on, we'll plug in for that x. B asks us how many bacteria will there be in 12 hours? 12 is a time, and we know x represents time, so I can take 12 and I can plug it in for x. So we'll do 24 times 2 to the power of 12, and we can type that on our calculator. And that's going to give me 98,304. And then C says, after how many hours will there be over 1 million bacteria? Now, for 1 million, that is not a time. And since it's not a time, we are not going to be plugging that in for x. This is actually a total. And when we're given a total like this, the only way that we know how to do this is to work backwards using our calculator. So we'll go through these steps on our graphing calculator. There's 2 main steps. Our first step is we're going to type our equation into the y equals button. So on my calculator, I'm going to go to y equals, which is in the top left corner. And I'm going to go ahead and type in that equation that I wrote. So I'm going to type in 24 times 2. Your exponent, we can do our caret key, which is over by the clear button, and then x, which is right next to the alpha button. So I can press x. Our second step is then we're going to go to our table, and to get to our table we're going to have to hit the second button first, and then we'll hit the graph button. So that's over here on the right hand side is our graph. So I'll go ahead and hit second and then graph, and that should bring me to my table. Now we're looking for when it's over 1 million. And if I kind of look here, if you're not able to see this, you can just scroll using your arrows, so we can scroll. I here see 786,000, and then it jumps up to this 1.57 E6. And we talked about that millions can't fit on our calculator because 1 million is actually 7 digits, and those 7 digits can't fit in this column. So your calculator actually would write that as E6 to kind of represent the 6 zeros that come after the 1 million. So when I see 1 E6, that actually means 1 million. So this 1.57 E6 actually means 1 million. So I can see that somewhere between my 15 and 16 hours is where we're reaching that 1 million. So we're going to write that as a range. So I'm going to say 15 to 16 hours is kind of how long it would take to reach that 1 million.